So here is an example of a problem we will potentially see in class, but also is useful for understanding some things that will happen with our graphs. So we have our function f of x, and we're given a point that's on that graph. And then we're given a function g of x, which is using f of x, but we're inputting x plus 5 into f. And the question we're asked is, what point is going to be on the graph of g of x? So let's think about our machine notation. If I think about the function f, all I know about it is that if I input 7, out comes 4. That is the absolute only thing I know about this function. For g of x, let's draw a bigger rectangle maybe over here. So here's my g function. It takes in an x, it turns that x into x plus 5, and then it plugs that x plus 5 into f, and then outputs f of x plus 5. So buried inside my g machine is an f machine. And the only thing we know about f is about the input 7. And so I need to figure out how can I make 7 the input for f. Well, in this machine, the input for f is x plus 7. Excuse me, it's x plus 5. Well, okay, so I need x plus 5 to be 7. In other words, x plus 5 equals 7, and so the x is going to be 2. So if I go ahead and I trace that through my machine, let's see what happens. If I trace that through my machine, well, let's do that in orange. All right, so I plug in x is 2. Let's do it down below since I already have the blue above. So x is 2. I input 2, and immediately I add 5 to that, so that gives me 7, which is good. So I take the 7, I plug it into f, and then I go over to my f machine, and I notice that when I plug in 7 to f, we get a 4. So this will output a 4. In other words, if I just look at what's going on outside the machine, we see we input 2, and we got an output of 4. And so the answer to this one is that 2, 4 is on the graph of g of x.